let's come over to the half life time of a first order reaction. तो हाफ लाइफ टाइम क्या होता है? जब हमारा आधा रिएक्शन पूरा हो गया होता है, कंसंट्रेशन कितनी बचती है? जब आधा रिएक्शन हो जाएगा तो कंसंट्रेशन बचेगी, इनिशियल जो कंसंट्रेशन थी उसकी हाफ बचेगी। यानी अगर हम यहाँ पर ले रहे हैं इनिशियल कंसंट्रेशन, अगर हम A0 ले रहे हैं तो कितनी कंसंट्रेशन बचेगी? एट टी हाफ, यानी जब आधा रिएक्शन हो चुका होगा तो कितनी कंसंट्रेशन बचेगी? A0 अपॉन, मीन्स A will be equal to how much? A0 upon 2. I should write it like this. At T half, A will be equal to A0 upon 2. Okay. When half of the reaction has been completed, okay, 50% of the reaction has been completed, then the remaining concentration will be A0 by 2. If the initial concentration is A0, then the remaining will be A0 by 2. So let's come on to our integrated rate law equation. We have T is equal to, beside the input over here, plus 1 upon K into 2.303 log of, I have taken this factor 2.303, so now I will take log A0 upon A. This is our initial concentration and this is the concentration after time t. Now when we are considering half lifetime, then we will have T half will be equal to 1 by K, let me write it directly, 2.303 upon K, 2.303 upon K multiplied by log of A0 upon, this A is now A0 upon 2 when half of the reaction is completed. So you can calculate it. This will come out to be 2.303 divided by K log of, if you calculate it, A0 gets cancelled and this 2 will come from here to the upper side and this will come. And we all know the value of log 2 is, how much is the value of log 2? It is 0.3013. If you calculate it, and it will come out to be 0.693 upon K. So this is the value of our half. This is our half life for a first order reaction. So what we see from our this equation is that there is no concentration term over here. Means the half life is independent of the initial concentration. Okay. What we see is that there is no concentration term over here, and so the half life will be independent of the initial concentration. This means suppose you take the concentration will be consumed, but it will be, the half life will be independent. Suppose the reaction takes 10 minutes and suppose the initial concentration is 10 molar and the reaction takes 10 minutes to reach its half life. Then if you make the concentration as 5 molar, then also the reaction will take 5 minutes, just now what I said, 5 minutes to complete that. Half of the reaction will be completed in 5 minutes. Okay, means if you take a reaction and it is 100% of A and it becomes 50%, means the T half, and the initial concentration is suppose it is A, no, let it be 10 molar is the initial concentration, and it is taking almost 5 minutes to reach, to complete half of the reaction, means this is our half life, 5 minutes is half life. Then suppose you take 5 molar concentration, then again it will take 5 minutes. But if you talk about the percentage of decrease in the concentration, that will be obviously different. But the half life will remain the same. Means it will not depend on the initial concentration, whether you have taken 10 moles per liter or you have taken 5 moles per liter. Okay? So this shows that the half life for a first order reaction is independent of the initial concentration. Now let's talk about the lifetime of a reaction. Lifetime of a reaction means when whole of the reactant is consumed. Means A becomes, our A over here will become 0. So let's consider this reaction. A will become 0. This T will be equal to how much? 2.303 divided by K log base 10. This is log base 10 of A naught upon A. Since we are calculating the time in which whole of the reaction will be completed, means the final concentration will become 0. So when the final concentration, suppose this is our lifetime reaction. Lifetime, I am getting, means A will become 0. And when this will be 0, that T lifetime will be equal to how much? Infinity. Means a first order reaction is never completed. In theory, in practice, it may the whole of the concentration may finish, but in theory, a first order reaction never gets completed. It can be only 99.9% completed, but it will never be fully completed. It will never be 100% completed. This is very important from the MCQ point of view. A first order reaction is never 100% completed. It can be 99.9% completed, but it can never be 100% completed. Okay. I will tell you a graph also. I will frame a graph also from this relation. Now let's come over to the average life. You all know average life is denoted by tau, and it is the reciprocal of, it is denoted by tau. Okay, it's a Greek word, Greek symbol, and it is actually reciprocal of the rate constant. Okay, so average life is given by, it will become 0.693 upon K. T half, it will become T half divided by 0.693, and it is 1 by 0.693 multiplied by T half. This is the relation between half life and the average life, and this comes out to be 1.44 into T half. You need to cram up these values from your multiple choice questions point of view. So, average life denoted by tau of a first order reaction is the product of half life and 1.44 constant. Okay, so this was all about the half life and the lifetime and the average life. The most important concept being that the half life is independent of the initial concentration, as I have told you here, and the lifetime of a reaction of a first order is infinity, means it is never 100% completed. And the third thing is the relation between the average life and the half life. So I will tell you in my next video about the graphs of first order reaction. I will tell you in my next class.